Good morning, everybody. Good morning, online. Can you see the screen? Can you hear me clearly?
Yes, sir.
All right. Can you see the screen?
Yes, sir.
All right, good. So we are doing this paper, the January 2017 paper. All right. So, as you know, at the end of it, you have to redo any question you didn't get right. All right. And if you did not do it, you need to go and do it, even after I do it. All right. That's the only way we're going to have the improvement that we need. All right. This pen is giving me a little bit of. Pen is giving me a little bit of challenge here. Let's see. I think I might have to change. Let me try a different pen. I've tested it before. It was working good yesterday. This one worse. I think I need a new tip. I don't think I can find now. So I don't think I can find a new tip right now. All right, let's try. Let's try and see. If anything, I pause and search for a new tip. There's supposed to be one in the bag there somewhere. But let's try. All right, number one. I left the calculator on the screen over here. As you know, this is a calculator question. This question says that use a calculator or otherwise to determine or calculate the exact value of this thing. So I want to type this thing in the calculator exactly as it appears here. All right, so let's go. So it's a fraction, and then we have a mixed number up there, which is 3.5. And then we are multiplying that with another mixed number, 1 2/3. And then we're dividing all of that by a mixed number, 4 1/5. And I'm getting 1.38, where the 8 is repeated. And so as a fraction, this is the answer right here. 25/18. I could put this one, 1 7/18. Since the question gave us mixed numbers, we can give them back mixed numbers. So the answer for this one is, and the pen is going, 1 7/18. 1 7/18. All right, that finishes that one. All right, next question is first to work this one out. Again with the calculator. Let's go back to the calculator. Clear it. It's going to be 5.47 minus the square root of a fraction, and it is 0.1014 over 1.5. That is 5.21. 5.21. That's the answer there. 5.21. Nice and easy. So we continue. This question now says the table below shows the number of tickets sold for a bus tour. Some items in the table are missing. This is a consumer arithmetic question. All right. Money spending to purchase tickets and so on. Hold on a second. second there. Somebody send me a message now that I've started. All right, so some items are missing. Calculate the value of P. So let's read what we have here. So these are the category of tickets. So you have juvenile, youth, adult, and this is the number of tickets sold. So 514, I don't know this one. This is a cost per ticket. In other words, a cost for one ticket. And this is total cost for each ticket on each line. So what it is that we're going to multiply these two values, right? And that will be equal to the value over here. All right, so the number of tickets times the cost for one ticket gives you the total on each line. All right, so we want the value of P. It's going to be 5 times P equals 130.50. We can write that 5 times P is 5P. That is equal to 130.50. So to get the P, we divide by the 5. So the P equals 130.50 divided by the 5. And so we can work out the value of P. 130. Huh? 36.1. All right. 36. So you have to put the 0, right? Remember, you have to put the 0 because it's money. So it's 26.10. So that's what the figure is going here. I don't have to put the dollar sign because you're basically filling in the table. Then they want the value of Q right here. And it is going to be that this one times this one equals to the Q. All right. So the Q equals to the product of those two. So the Q is going to be equal to the 14 times the 44.35. Again, is money. So you can tell me what that one is since everybody know. That figure, 620 point, you have to put the money, you have to put 090. You can't put 0.9. It's money. So it's 620.90. That's the figure going in the table. Again, you don't have to put the dollar sign. But you're writing the values that will go in the table. Then they said down here, an adult ticket is twice the cost of a youth ticket. Let's look at that now. The adult one, this one, well, this is the number of adult tickets. So this cost here we're talking about, it is 2 times the cost of a youth ticket. So it means that the value inside here, let's put it in, is 2 times the 44. So this here becomes 2 times 44.35. 2 times the cost of a youth ticket. That's what it said, right? So the cost of a ticket here is 88.70. Multiply that by 2, I get 88.70. And I want the value of R now. And so again, it's going to be R times this value equals that value. All right, that's what it's going to be. And I'm leaving this workout on the paper, and it's accepted to leave that working out on the paper there. So it's R times 88.7 that is equal to this one. Let me write it here and then copy it down. So it's going to be R times 88.70 that is equal to this 2483.60. So this is our equation that we have to solve now. Let's cut it and put it down here. Part 3. All right, so I'm going to put it there. And so the R that I want, oh, the pen really giving me hell. Do not have to search for that thing. The R becomes equal to 2. I want to show the work. But the pen giving me hell. All right, I think I need to change the pen part. 2483.60 divided by 88.70. What you get? 28?
Yes, sir.
28 tickets. All right. Next part says the bus company pays taxes 15% on each ticket sold. Calculate the tax paid by the bus company. So the tax the one. So the tax is 15% of the total. So we're going to have to calculate the total amount of money that was collected for the tour. And the total amount of money is the total right here. What was Q again? We need the Q figure for here. 620.9. Let's put it here. So this figure was 620.90. And so we can get the total down here by adding that up. So it's 130.5 plus 620.9 plus 2483.6. So it's a total of $3235. And they're paying tax on that, right? So tax on that. So the tax becomes 15%. That's what they're asking us in order for the tax. Calculate the tax paid. The tax is 15% times that amount of 3235. That becomes your tax. So so it's 15% or 0.15 times 3235. I'm gonna put the money on it, 485.25. What I got that?
Yes, sir.
All right, good. And that finishes the first question, huh? 0.24, that's all right. That's okay. They give it a mark still. All right. All right, let's continue. All right, down here now. It says, write this as a single fraction. I don't think I need the calculator. Write this as a single fraction. What it is again is that we want the two denominators to be the same. All right, so we want to multiply this denominator up here and down here. So multiply this one by 4/4. Multiply this denominator up here and down here. So multiplying this fraction by 3/3. So that way the two denominators become the same, the fractions will then be related. So it becomes equal to the 4 times the 2x is 8x. The 4 times this 3 is positive 12. Divided by the 4 times this 3 under here is 12. Then we're adding, that's this plus, we're adding 3 times x is 3x. 3 times -4 is -12. Divided by 3 times this 12 under here is 12. Now the two denominators are the same, fractions are related, they're gonna have a final answer with the same denominator. 8x and 3x is 11x. And 12 and minus 12 give you 0. So the answer is that 11x over 12. Nice and easy. Do it some other way and get the same answer. Good. Right? 11x over 12. Next question. Write the following statement as an algebraic expression. Write the following statement as an algebraic expression. So it says the sum means plus. We're going to be adding the numbers of a number, which it didn't tell us what the number is, we can call it n, and its multiplicative inverse. The multiplicative inverse of n is 1/n, and we're adding them to get the sum. 1/n. That's the inverse of this. Is means equal. 5 times the same number, that's 5n. That's the expression. If you use x, no problem. That's it. The sum of a number, that's the sum, a number and its multiplicative inverse. Inverse is 1 over the number for multiplication. Is mean equals 5 times the number is 5n. So if you use x instead of n, no problem as a number, right? So if you could write x plus 1/x equals 5x. Same thing. All right, anything you use for the n, any letter you choose to use, no problem. But that is it. All right, that finishes that one. Next one. You want us to factorize this thing. This clearly is a difference of two perfect squares. So we're going to write it as a difference of two perfect squares. Right here. So first we're going to write it as x squared minus 6 squared. And so you factorize the difference of two squares, it becomes the difference of the two numbers times the sum of the two numbers. And that is it. So that's the final answer right there when you factorize it. All right, difference of two squares. Then we'll come to this one now, that's a quadratic. Let's practice breaking out the middle term for this one. We're going to break out this middle term, all right, by going to the process. All right, so what's the process? We're trying to find, I want to find a way to break this out into four terms, the whole thing out into four terms. So break this out into two terms. What do we do? Multiply the two n coefficients first. That's 2 times negative 12. That gives us negative 24. We're looking for factors of negative 24 that add to the middle coefficients of positive 5. You can see that it's 3 and 8 right away. So if you don't see that it's 3 and 8 right away, then you can search for them. Let's just search for them just to practice how we would search for them if you didn't see it right away. First two factors of 24 is 1 and 24. So we write down the 1 and the 24. One of them must be positive and one must be negative because we're trying to find the factors of a negative number. So because you want the sum of those two factors to be positive like this, you get the larger of these two factors the positive sign. So it will be positive 24 and negative 1. Then you add them. But when you add them, you get in 23. Because 24 minus 1 is 23. You don't want 23, so I'm putting the x on that. You're searching for 5. You want the sum to be 5. So the next two factors of 24 will be 2 and what? 2 and 12. Again, I'm going to get the larger one the positive and the smaller one the negative. But then 10 and minus 2 is 10. 12 and minus 2 is 10. You don't want 10. You're looking for 5. So you go to the next factors of 24, just 3 and what? 3 and 8. Then you get the larger one the positive again and the smaller one the negative. And then 8 and minus 3 is a positive 5. So you're good now. You have found the 5 that you want them to add to. So it means that you're going to break this middle term into minus 3x plus 8x. Or you can put the plus 8x minus 3x. All right? That's what we're going to do. So let's do it now. So this expression becomes, let's go back for the blue. This stays as it is, which is 2x squared. This middle term, as I said, is broken out using these two factors, which is 8x minus 3x plus 8x minus 3x. If you wanted, you could put minus 3x plus 8x just the same. It doesn't matter how you put these two. All right? And you must always check to see that what you split it into would give you back the middle term. Always do that check, which it does. And then this minus 12 comes back. Minus 12. And so you have created a situation where 4 terms are going to factorize by parts. So you're going for the highest common factor in these first two terms. Highest common factor is 2x, not just a common factor. The highest common factor is 2x. So factorize 2x out of these. Out of this one, I'm left with an x. Out of this one, I'm left with a positive 4. Because like you divide this by the 2x, you're going to get 4. The same thing in the bracket must end up over here. So I'm going to write that back first. X plus 4. Then in between here now, must have plus a value or minus a value, some factor. Don't just put a value there. Plus a value or minus a value. What value must go there? You can know what factor that is by dividing this negative 12 by this 4, for example. Negative 12 divided by 4 is negative 3. Or you can divide this negative 3x by this x. Negative 3x divided by x is negative 3. So you're factorizing a negative 3 out here. If you're not sure, you can multiply it back again to get these. And so the x plus 4 now is a common factor. And it says 2x and a minus 3 times a common factor. That gives you a final line. So you end up getting 2x minus 3 times the common factor of x plus 4 now. And that is it. This can't be factorized any further. All right, that is it. If you put these two the other way around, still correct. If you have the x plus 4 in front of the 2x minus 3, still correct. But those are not your two factors. All right, let's move on. Next question says, they give us this formula for volume of a cylinder. V equals pi r squared h. They want us to make r the subject. So we have V equals pi r squared h. I always say to the students, don't try to move the r that you want to make the subject. Move everything away from the r when you can do it that way. Because sometimes persons try to put this on the left side and mess up with the negative sign and all of that. Just think of it, you want to leave this by itself, and so you're moving everything away from it. You're moving the pi, you're moving the h, you're moving the square. Good? So the first thing you want to do is move this pi and this h. Since they are multiplying, we can divide them onto this side. All right? So we divide both sides by the pi and the h. We're going to get the volume over the pi times the h. We're left only now with r squared. Then we need to get rid of the square. The inverse of square is the square root. So it is as if we are now square rooting both sides. Square root this side and square root this side. And this square root basically eliminates that square and left with the r. All right? So it's like a square root both sides now. Let me leave that in red. And so the final answer then is that this side becomes a r. Is equal to the square root of v over pi h. Since I put r as the subject, I'm going to rewrite it and put r on the left side now. Let's turn it around. And so r is equal to the square root of v over pi times h. That's his answer right there. All right. This one now says, they're telling us that this, when it compute the square, it becomes that. They want us to tell the value of a and b. Multiple ways to do this. But for me, the easiest way to do it is to expand this out into the standard form, and then you'll see what the a is and what the b is. For me, that's the easiest way to do this one. Expand out the right side, and you'll be able to see what the a is and what the b is. All right? So, this side, if I expand it out, remember I expand out the perfect square first. If I expand the perfect square, I must get 3 terms. Remember, I get 3 terms, right? So you're going to get the first term squared, which is x squared. Then you're going to get twice the product of the 2. Or the twice the product of the 2. Multiply these two things. You're going to get positive 2x. And I will double it to positive 4x. So the middle term is plus 4x. Then the second term squared is 4. Now, all that I have here so far is this. Expansion of that. So now I have to subtract this 3 now. Subtract that 3. So I'm subtracting 3. When I simplify this now, I get x squared plus 4x. This works out to 1. So when I compare it with this, I can see that the a is 4 and the b is 1. Easy. So I can say, therefore, the a is 4 and the b is 1 when I compare them. So expand out the right side, set it up like the left side, and compare the values. Simple. All right, next question. Oh, that one finishes that one. The 2 questions done, 8 to go. Let's go. Next question. All right. Oh, this is 11 questions paper. 11 questions paper. Want to do this one still. So remember, you were supposed to do this one after. So if you didn't do it, you need to go and do it. Because sets is not the multiple choice. You still have to know to do sets. Even though sets not coming on the paper 2 anymore, it's coming on the paper 1 a lot. Up to 8 questions, 8 to 10 questions on the multiple choice will be set. All right, so you have to master sets. All right, this one says the incomplete Venn diagram below shows the number of students in a class of 28. I'm going to put the 28 right here from now, so I don't forget. That everything must add to 28. I'm putting it right here. 28. I don't want to forget that the total in there is 28. All right. It says you are the students in the class, F are the students who play football, T are the students who play tennis. It says additional information about the class is given. 12 students play tennis. So I'm going to put that 12 here. It means that here and here add up to 12. It says 15 students play football. I'm going to put a 15 on this one. Put a 15 right here. It means that this and this add up to 15. Total in football is 15. It says 8 play neither. So the 8 that plays neither must be somewhere out here. Anywhere outside there. And then X play both. That is the X that they have inserted first there already. X play both. All right? And I want us to complete the Venn diagram. So we're missing this subset and this subset. We have to fill them out. All right? Let's fill them out in blue. Well, this would be a live value. Write it in red, in blue, sorry. This one, I'm going to put the 8 in blue. And then since here must add up to 15, and this is already X, then inside here is 15 minus X. And since here must add up to 12, and here is already X, then here must be 12 minus X. That's a completed Venn diagram. All right? Then it says calculate the value of X. To calculate the value of X, what we know is that the total everywhere is 28. I'll put another way. If out here so is 8, then inside here total must be 20. Look at it that way as well, you know. And the total is 28. So if the 8 in the 28 is already accounted for out here, then the union inside here and this must be 20. But we can just do the normal way and say, okay, the total is 20. Let's write it out here and copy it down. So this part is already 15. So I'm going to write back 15 minus it. That part is already 15. So it's going to be 15 plus this, which is 12 minus X, plus this 8 out here. All of that equals 28. And right away, if you subtract this, you're going to get the 20, but no problem. We're trying to make X a subject. So transpose the minus X over here and get X equals, this becomes 27 plus back this 8 and then subtract this 28. So it's like 27 minus 20 give me 7. So X equals 7. So the answer is 7. Let's put it down here. Let's calculate the value of X. That's it. X equals 7. Simple thing, all right? Total is 28. Let's continue. This one wants us to do a construction. Using a ruler, pencil, a pair of compasses, construct a trapezium ABCD. AB must be 8. Let's sketch it and never construct it. AB must be 8. I'm going to sketch it first. So I'm going to put AB on here. I'm going to make that 8 centimeters. AB must be 8. The angle at A must be 60 degrees. So I'm going to put a 60-degree angle right here. And then, so D is going to be up here, so. And AD must be 6. So this must be 6 centimeters. And then the angle over here must be 90. Angle at B must be 90. So I'm going to put a 90-degree up here, so. All right. And then AB and CD parallel. So C is going to be here, but these two parallel. This line and this line parallel. All right. So that's what we're constructing. All right. This line and this line parallel. All right. So we're going to have to construct the parallel to this up here. All right. Also, we could say since this is 90, then this is also 90, as these two lines parallel. All right. But that's what we're constructing. All right. Let's go. Let's construct it over here. Sketch it and we'll construct it. Where are you? All right. Let's sketch this thing. All right, I'm going to draw the AB first. So I'm going to get the ruler. I'm going to draw 8 centimeter line. That's my AB. And then from here, I'm going to construct my 60-degree angle. So bringing in my compass. Push it at the end of the line, lock it. Let's change the color for the construction lines. Let's make it zero. Yeah, let's do it like that. I want to construct a 60-degree angle. Only 2 arcs needed. So there, move the point to here where the intersection is. And rotate it up. Oh, I made a mistake. I opened the compass. Let me undo. Let me start over. Let's go again. I have to lock the compass. I can't open the compass. So go there again. Move the point to here. Rotate it up. And cross that one. That is 60 degrees. At the other end, I'm going to construct my 90. That's my 60 degree through that intersection. So for the 60 degree, for the 90 degrees, sorry, I'm going to construct 2 60-degree arcs. So I'm going to construct a big 120 first. Big 120 all the way around here. Move the point to here. Cross that one. That is 60 degree. Move the point to here. And cross that again. That's another 60. So up here, we have a 60-degree arc up the top here. So I need to bisect it to 30. So to bisect that one, rotate up here, make an arc above it from that end of the 60-degree arc to the other end of the 60-degree arc over here. Position the compass and cross that one. That's gonna be my 60 degree, my 90 degree, sorry. So I just need to draw now a straight line through the intersection. Now remember, the line that I'm drawing through here, through the 60 degree, it has to be 6 centimeters long. All right, so I'm going to draw a line through here. I want it to be 6 centimeters. You know what? Let me measure a 6 centimeter arc from now with my compass. So I'm going to measure a 6 centimeter arc from this end. Use a ruler to measure 6. You could use a ruler itself, but I'm going to make an arc for the 6. Open it up to 6. Lock it. Let's change the color for the 6 arc. I'll put it here and make an arc at the top. That is 6. That is 6 from A. So when I draw my line through the intersection here now, I'll show you. Through the intersection, and it meets here, that is where 6 is on that blue line. So where it meets that blue line, that is 6. Because that is 6. And I draw it through the intersection. That's a 60 degree, 6 centimeters. That's it. So it means that right at the blue line there is D. So all I need now is a parallel line to the baseline that I have. Right? And a parallel line to the baseline now. So I'm going to take that baseline, the AB line, mark it. This AB line that I have down here. I'm going to construct a parallel to it. So it's like I'm constructing a parallelogram first. All right? I'm going to use a compass and do it. So it is as if this length that is already 6. This length that is already 6 that I have. I'm going to transfer that length over this end. That means a different construction in blue. Make an arc. It's in black. Let me change it to blue. And then this length down here on the baseline, the AB line, which was 8. I'm going to transfer that length up the top. So this out to 8, lock it, transfer that length from here, and make that arc. So it means that when I draw a line, horizontally, it's going to be perpendicular. But watch this, I'm going to draw the 90-degree line first, and then let them meet. I'm going to draw the 90-degree line first at B. Let's draw that in first. The 90-degree line through here, through this intersection. That's the 90-degree line. Then I'm going to draw in the parallel line at the top now, which is here. Be the blue to blue. That line there, blue to blue. Through the intersection. So it means that I want to put in my points now. That is A and B, right here is C, and right here is D. And that's my construction. This length down here is 8 centimeters. Up here is 6 centimeters. This is 60 degrees inside here. And right here is 90 degrees. That's my construction. Watch over the video, get the geometry set, and try doing it. All right? Get the geometry set and try doing the same thing. All right, so that is that. Let's continue. Oh, let me see. See, it's a problem. Anyway, that is it. Next question. Not to measure anything, nope, that is it. 7 marks for doing that. Let's get this off. Now come to this functions question now. Question 4. It gives us these two functions. Wants us to find g of 0 plus g of 5. So I'll plug the 0 in there and then plug the 5 in there. Both of them going in the g function. This becomes equal to the g of 0 first. I put in 0 there. It becomes 3 times 0 plus 1 over 2. Then you're doing g of 5. You got to put 5 in there now. You're going to get 3 times 5 plus 1 still over 2. So because they're on the same denominator, this numerator becomes a 1 over 2 plus this numerator becomes a 16 over 2. 16 and 1 is 17 over 2. That's the answer, 17 over 2. Huh? If you leave a mixed fraction, no problem. So you could put 8.5 if you want it, same thing. Right, 8.5 like this, still correct. All right, next question. I want f of g of 5. So f of g of 5 means I want to put 5 in the g function. But look here, we basically have the g of 5 here already, you know. This is g of 5, you know. It's already equal to this 8. So from up here, we already know that g of 5 is 8. So we have to work it out again. All right, the g of 5 from up here is equal to this, which is 8. So g of 5 is 8. So therefore, if we want f of g of 5, watch this now. From this thing now, f of g of 5 is the same as f of 8, but the g of 5 is 8. And then f of 8 then means that we're going to substitute the 8 in the f function now. So that becomes 4 times 8, and is what? 4x minus 7. So it's 4 times 8 minus 7. What that work out to? That becomes 32 minus 7. How much is that? 25? Huh? 25. That is 25. Nice and easy. All right, let's continue. Then we want f to the minus 1 of 1. So to do this, we're going to find f to the minus 1 of x first. Then we do the f to the minus 1 of 1 from it. That's not the only way to do it, but that's the approach we're going to use. What do we have? We have f equals 4x minus 7. We're going to inverse that first. The f becomes x, and the x here becomes f to the minus 1. So we get 4f to the minus 1 minus 7. They want to make this the subject. Make that the subject, we're going to add the 7 over here and then divide under the 4. So we're going to get x plus 7, we'll add the 7 and then divide by the 4. That leaves us with f to the minus 1. So this is really f to the minus 1 of x now, you know. It's really f to the minus 1 of x now. So that will complete this part. And then from here now, let's change the color. We can then say that this then implies that f to the minus 1 of 1, you got to put 1 here now. It becomes 1 plus 7 over 4, which works out to be 2. 8 over 4 is 2. So the answer is 2. All right, but good with that? All right, let's continue. Then they give us this 2 points. P and Q are endpoints of a line segment PQ. They want the gradient. We all know gradient is rise over run, sorry. Difference in y over difference in x. Remember, the direction you go when you're taking the difference in y, you must go the same direction when you're taking the difference in x. Let's try to like this. Gradient of PQ, MPQ. Is the difference in y over difference in x. Mute the mic, please. Mute the mic. Somebody just. All right. So I'm going to use this point minus this point. Remember, I do the difference in the y values first. So it's this y value minus this y value. Rise the difference in the y values. So we're going to do 7 minus this y value is a negative 1. Divided by, you have to do now this x value minus this x value. Same direction is subtract them. 2 minus 6. So this becomes 8. This is negative 4. 8 over negative 4 is negative 2. So that gradient that I want is negative 2. Negative 2 is the answer for that gradient of PQ. What else do they want? They want the coordinates of the midpoint. Remember, the midpoint is like an average point. Right? The midpoint is like an average point. Let's write down the points. P is 6, negative 1. And Q is 2, 7. So the midpoint is like an average point. Let's call the midpoint capital M. Capital M for midpoint. The average of these two x values, that's 6 plus 2 over 2. Then the average of these two y values, that's negative 1 and 7 over 2. And so the midpoint M, capital M, this becomes 8 over 2, which is 4. This becomes 6 over 2, which is 3. So the midpoint on PQ is this point, 4, 3. Nice and easy. Midpoint like an average point. Then they want us to get the equation of the perpendicular bisector. Students online, can you hear me still stand still to the screen? Students online?
Yes, sir.
All right. Then I want the perpendicular bisector. What's a perpendicular bisector? The line that bisects and is also perpendicular. Bisector. What does bisector do? Passes through the midpoint. Let me sketch it for you. So it's like I have Q up here and I have P down here. This is a schematic, right? And this is the line segment PQ. Hold on a second. And they want the perpendicular bisector. So the line that they want will go like this. Let's call it line 2. It passes through the midpoint of PQ, the capital M point that we just found, which is a 4, 3. And it is also perpendicular to PQ. To find the equation of this perpendicular bisector red line, we need to know two things about it. We need the gradient of it, and we need a point. We have the point already, because it passes through the midpoint. What we need is the gradient. Since it is perpendicular to PQ, it has a negative reciprocal gradient of PQ. Let's call it line 2. So the gradient of line 2, M2, is minus 1 over the gradient of PQ. Which means that we take this 2, that this gradient was up here, negative 2, sorry, and put it under here. Or flip it and change the sign. We're going to get a half for that perpendicular gradient. We put the negative 2 under here. The negatives will cancel, we're going to get a half. So the gradient of that red line is a half. Then the red line also passes through this point. Should have done this in red. Let's do this in red. As if we are suggesting that we're finding the red line. Let's change this to red. So using this gradient now, and this point to get the equation. So the equation that they want becomes y minus ym, because m is the point that we're using, equals the gradient of line 2, that's this gradient of line 2, was line 2 we want, into x minus the x value at the point. That is called the point gradient form for the equation of a line. Very useful. So substituting the values now. Y minus the y value at the midpoint is 3. Equal the perpendicular gradient is a half. So put in a half here. Into x minus x value at the midpoint right here is 4. Since this is half of that 4, going to give us a whole number. We can just expand it straight and put y minus 3 equals half x minus 2. Half of 4 is 2. Then this 3 comes over, become a positive 3, and then the 3 minus 2 is 1. So it reduces to y equals half x plus 1. That is the equation of the perpendicular bisector. Half x plus 1. Very good? If you did not get it, you need to go and redo the question. But at the foolishness, go and redo the question. All right. All right, next question. Similar triangles. As soon as I see this, I know it's a similar triangles question. Remember, if you have a triangle, you have a line in it that is parallel to one of the outer lines, you have formed similar triangles. So this one up here will be similar to the outer one. All right, and when you have similar triangles, the ratio of corresponding sides are equal, 3 angles equal, and the ratio of the area is the ratio of the square of corresponding sides. They ask anything about area. All right, I'm just repeating that for the purpose of the lesson, you know, for revision purposes. This question says PQR and STR are similar. Actually, tell you, they give it away. So where are they? The PQR is the big one. It's similar to the red one, the small one. So those two triangles are similar triangles. The blue one and the red one. Big one and the small one. All right. It says complete the following statements. In the diagram, the corresponding angles of PQR and STR are equal. Similar triangles have equal angles. They are equal. They are the same. And the something, the what? The ratio of the corresponding sides are equal. They are the same. The ratio. That's what you have to know. The ratio of the corresponding sides are equal. That's what happens in similar triangles. The ratio of the corresponding sides are equal. All right. It says now, in the diagram above, not drawn to scale, it says RS is 50. Let's put on some dimensions on the diagram. RS is 15. Let's put them on in purple, the dimensions. So right here is 15. And let's put on in red. So this dimension RS is 15 here, so. And with centimeters. SP is 9. So right here says 9. This piece right here says 9. Let's put that piece in blue. So if this is 15 and this is 9, then the overall length on this side, which is on the big triangle, let's put it on. The overall length on the big triangle down here is what? 24? It's 24. 9 plus 15. All right? That's that side. So the 24 corresponds to the 15, you know. Those are corresponding sides on the two triangles, right? And then it says ST is 12. ST is this length right here, so it's 12. So let's put that on this side now. This is 12. So how the ratio works now, for example, is that this 15 over this 12 is going to be equal to this 24 over this side. The ratio of corresponding sides are equal. So we can say on the small triangle, slant up over base equals on the large triangle, slant up over base. The ratio of corresponding sides equal. Get me? That's how it works. So the question is asking us for PQ, which is this side down here, which you can use the ratio and get. All right? So if we set it up, you can set up like this. Let's do it this way. You can set this base over the height, or the big one, right? So the base, which is PQ, so you can say PQ over the 24 on the big triangle, that's that ratio, base length over the slant length up there, equals the base length over the slant length on the small one, 12 over 15. That's how the ratio thing goes. And then to get the PQ now, we'll just multiply the 24 by yourself. And so the PQ would simply be 12 over 15 times 24. Whatever that works out to is the answer. What that work out to? Want to get for that? Can simplify it down. What that work out to? Huh? 19? 19.2? All right. 19.2. 19.2. You can just double check it. Because 12 divided by 15 is 0.8. And so 19.2 divided by 24 is also 0.8. All right, good. So I know it is correct. But the ratio comes to the same thing. That's it, 19.2. And they said the length of it, I'll put the centimeters on it, right? I have to put the centimeters on it. It asks us for the length. So let's do the thing the right way. You have to say centimeters. 19.2 centimeters. All right, let's continue. This now is a transformation question. It says the diagram below shows triangle DEF and D prime, E prime, F prime after transformation. So the transformation is from this one to this one. Let's figure out what is happening before we start. Let's figure it out. Music ready. So DE, for example, this way is now DE this way. So that tells me that there was a 90-degree rotation, but this rotate up to that way. It was horizontal and it's now vertical. So I already know that we have a 90 degrees anti-clockwise rotation. All right. Then the next thing now is where is the center of the rotation? Now, most times the center of the rotation is the origin. And we can just double check that this is the center of the rotation. By just checking a couple points. If you rotate a couple points, 90 degrees. So like you're rotating, for example, the coordinates of E. Coordinates of E will be this and that. If you rotate this L-looking thing 90 degrees anticlockwise, this long side is going to rotate up to here, and that is what, 4 units. And the short side at the top, which is 2 units, is going to go 2 across the top. That looks correct. Like if you rotate this L-looking thing 90 degrees this way, it's going to become this to position E prime. That looks like the center of rotation is 90. Let's do another point. If we work for 2 points, you're good enough. Let's do this point. This point is 1 across, 2 up. If you take this thing and you rotate it, then this short piece is going to come here. This long piece at the top is going to go 2 across to here. So if I rotate this thing 90 degrees anticlockwise, it's going to come to here. That's a way to check it. So it maps this point onto this point. So I can conclude that the center of the rotation is the origin. Simple as that. You can also just do a straight line, this to this, rotate to here. You can see that right here is 90 degrees. Right? You rotate this to here, 90 degrees. Or you can use the same D again. Rotate 90 degrees to here. See 90 degrees there. Looks like it. Then you can look at E. Or F, sorry. Here. Rotate 90 degrees to here. See, this angle is 90 degrees. The rotation is this. So we can conclude that the center of rotation is the origin. All right, so we know that already. So but let's answer the questions now. I want to give a question the most asked for it. Most 90% of the time, they're going to ask to describe the transformation. First part, though, wants us to state the coordinates of E, which is this point. So based on this scale, right here will be 2, and right here will be 4, and up here says 2. So this point is 4, 2. 4 across, 2 up. 4, 2. Let's make sure. E is the point 4, 2. That's it. Describe fully the transformation. Because a rotation, you must give 3 components of rotation: angle, direction, and center. So the rotation is an anti-clockwise, that's what we decided. Angle is 90 degrees, rotation, it is a rotation about the origin. Center of rotation is the origin 0, 0. So what have we given? I've given the name of the transformation and the 3 components: angle, direction, and the center. Angle, direction, and center we have given. Remember, the anti-clockwise rotation is also positive rotation. So you could have also said positive 90 degrees about the origin. Anti-clockwise rotation is positive rotation. You have to remember this. Clockwise rotation is negative rotation. All right? So we could have said positive rotation instead of anti-clockwise. All right. Next part now says, on the grid, we have to draw the double prime triangle, which is a reflection of the prime triangle in the x-axis. So reflecting the prime triangle in the x-axis. So that's this one. Reflecting this one in the x-axis. Hold on a second. Neville, I'm in class. I'm in class. What's up? I'm in class, Neville. I'm in class. When am I done? When I go leave class to come. I done my class first. When am I done? Then at 4 o'clock I normally finish. Then you have to tell me from yesterday, I wouldn't know that. But we'll come before that, man. I'll come before that. All right. All right. All right, cool. All right, guys. Sorry about that. That was work. All right, so I'm going to reflect this now in that line. All right. So reflecting this point first, It's 1 unit from the mirror line. It's going to go 1 unit on the other side. So this point is coming to here. Let's put it in first, F double prime. And this point is also 1 unit to the mirror line. It's coming 1 unit on the other side to here, which now is D double prime. And this point is 1, 2, 3, 4 to the mirror line. It's going to go 4 on the other side, down to negative 4. 1, 2, 3, 4. So it's coming down to here. That is E double prime. And so we draw that triangle. And that is that. All right. Nice and easy. All right, then we'll come to number 6. So the question gives us this as a scale. Another person was asking me about this. If they give you a scale of 1 to 1,000 to 25,000, this is on the map. This is on the land. Maps are measured in centimeters, because map, you're not going to put meters and kilometers on a map. A map is like on a piece of paper. So those are small measurements. The measurements on map will be more likely in centimeters. But this means that 1 centimeter on the map is 25,000 centimeters on land. That's what the scale is. It's just that on the map, you're going to be working in centimeters. So we know that the map side is going to stay centimeters, but you want to convert the land side or the actual side to a larger unit of measure, like meter or kilometers. We have converted 25,000 centimeters now to either meters or kilometers, depending on what I want in the question. All right? So this question said, determine in kilometers what the actual distance is. So we know that we're working in kilometers. So I want to convert this scale firstly into a kilometer scale. So go from centimeters to kilometers. You divide by 100 first to get meters, and then divide by 1,000. 1, 2, 3 to get kilometers. I'm going to go step by step for you. So when I give you this scale, as I said, let me put it over here. It means that 1 centimeter to the map is 25,000 centimeters actual. 1 centimeter on the map is 25,000 centimeters on the land. You want to convert this to meters, you divide by 100. So 1 centimeter on the map is 250 meters on the land. If they want in meters. But since I want kilometers, we divide this now by 1,000, because 1,000 meters make a kilometer. So then 1 centimeter on the map, this now is 0.25 kilometers. So this is a scale now for distance, if you want to go from centimeters to kilometers. So when they ask you for 3.8 centimeters, you're multiplying this scale by 3.8 to get the actual distance in kilometers. That's how it works. So let's go now. So 1 centimeter is 0.25 kilometer. Since we want 3.5 centimeters, you want this side to become 3.5. You multiply this ratio by 3.5, as simple as that. 31.8, sorry. I said 3.5. 31.8. I want this side to become 31.8. So when this side becomes 31.8, that's on the map, you will see what the actual distance is in kilometers by multiplying that also by 31.8. I want to get for that now. How much you get? All right, 0.25 times 31.8. 7.95 kilometers. So this is 7.95 kilometers. So that is the distance, actual distance. That's the answer right here. All right, so you can write that. The answer for this question is 7.95 kilometers. That's the actual distance. It said, no, what is the actual distance? It tells us now the actual distance between these two places is 2.75. How many units on the map that represent? How many units apart are they on the map? So the same ratio we can start with. So we can say, okay, start with the same ratio. 1 centimeter is 0.25 kilometers. I kind of simple now. You want this side now to become this on the ratio. Right? You want this side to become that. So what you can do, you can say, okay, what would I have to multiply this by for it to become 2.75? You can divide it to know what to multiply it by. So if I do 2.75 divided by, it's actually 4 times enough. 2.75 divided by 0.25, I have to multiply by 11 for this side to become 2.75. I want this side to become 2.75. I have to multiply it by 11, not divide, multiply this by 11. So multiply it by 11, multiply the ratio now by 11. And multiply the ratio by 11. This side becomes 11 centimeters. Today, this side becomes what we want, which is the 2.75 kilometers. So it means that 2.75 kilometers is 11 centimeters on the map. So the answer for this one is 11 centimeters on the map. Simple as that. Do it like a ratio question. And ratio questions can be done simply by multiplying and dividing by values to get what you want. Simple as that. But I go to that. All right. Next question. Next question says, the diagram below shows a square ABCD drawn inside a circle. ABCD drawn inside a circle. It says the vertices of the square lie on the circumference of the circle, as you can see. It says the length of the side of a square is 11 centimeters. So each length of the side of a square is 11. So we put them on the diagram. Then this is 11 centimeters. 11 centimeters. This is 11 as well. Let's write 11. This is 11. That also is 11. All right. Now, because this is a square, guys, it means that the 4 vertices are 90 degrees, or the 4 angles in there are 90 degrees. So this is a 90-degree angle. So this has to be a diameter. Why? Because remember, it's a diameter that subtends 90 degrees. So this length has to be a diameter. So if you find the length of AC, you would have found the length of the diameter. Has to be a diameter. Angle subtended by a diameter is 90 degrees. So that's the premise on which you're going to calculate the diameter. So it's a show that the diameter is 11 points. So I would tell them that the diameter is AC here in this question. Right? So I would indicate that the diameter is AC. I said that is AC, something like that. So something like IE, AC. You calculate AC, that's what you're gonna get. But you're gonna work in the right angle triangle here now. It's Pythagoras theorem in the right angle triangle. Because this is a right angle triangle, you calculate it AC. Pythagoras theorem you're gonna use. So AC is going to be the square root of 11 squared plus 11 squared. 11 squared plus 11 squared. Which becomes, the square root is 2 times 11 squared we have. 2 times 11 squared. Or we get the answer to look like theirs. Simple. Let's continue right here. This 2 times 11 squared means that we can square with the 2 and also square with 11 squared. All right, so we're going to get the square root of 2 times the square root of 11 squared. The square root of 11 squared is just 11. Just 11. So then it becomes square root of 2 times this 11 right here, which then is 11 times the square root of 2 centimeters. I think I did more work than I needed to, but just to try, to show some work. But that is it. All right, that's it. That is how you show it. It is AC. All right. So next question says, calculate correct two decimal places the area of the circle. Now, if this is the if that is the diameter, I'm going to write that the radius is half of that. You know, the radius is half. I can just put it over 2. The radius becomes my radius, centimeters. We tend to work in radius. We're doing circles. We don't work in diameter. We tend to work with radius. So let's keep it simple. Then what the area of the circle? The area of the circle is pi r squared. What did they must use pi r? Did they tell us? Did they tell us sometime? They tell you at the end of the question. They didn't tell us. So we're going to use the original pi. I would like we can use 22 as but that's a 2 decimal places. So we're going to use pi on the calculator. They didn't tell us anything for pi. So the one the area of the circle, pi r squared. I'm taking this as my r. So I'm going to write the area of the circle. AC for circle is pi r squared. Pi r squared. So it becomes pi times 11 root 2 over 2 squared. That gives me the area of the circle. And I wrote this out. Put that in the calculator. See what we get. All right. So I'm going to get pi times a fraction 11 times the square root of 2 over 2 for the radius. And I'm squaring that. So I get 190. I'm saying 2 decimal place. So that's 190.07 centimeters squared is the area of that circle. Huh? Huh? What do you get for your answer? What do you get? That's all right. Because that depends. Because they didn't tell what to use for pi. All right, so make it a rule going forward. Pi is on a calculator. They don't tell you what value to use for pi, use the pi on a calculator. All right? So going forward, if they don't tell you what you must use for pi, use the pi on the calculator. Remember, I was looking for what they said to use for pi. All right? Good. But they will give you the marks still. Right? Not a big deal. They'll give it us. So you get 189, that's fine. All right. Next one wants the area of the square. That's just 11 times 11, right? Let's call it AS for square. Is 11 times 11 as a square, which is 121. That's all. 121 centimeters squared is the area of the square. Then I want the area shaded. Let's look at the diagram now. So we want to figure out the area shaded. We'll subtract some areas. So I think we're going to get the area shaded. Huh? Now for do that, man. But I won't give it. If you do the area of the circle minus the area of the square, you're going to get all of this area around as a 2. They divide it by 4. But the 4 areas will be the same. If you do the area of the circle minus the area of the square, if you do the area of the whole circle, and you subtract the square inside here, so then you are left with the area all the way around here, all these segments here, you're left with all 4 of them. But only one of them, all of them are the same. So to get the area of one of them, you're going to divide by 4. But understand that? So we can just write a simple formula for the final answer. That's the area shaded equals area of the circle minus the area of the square. That gives you the 4 segments, and divide it by 4 because only one of them you want. They're all equal. That's what you're working on. Youngster, put on your phone number and pay attention. So this becomes equal to the area of the circle was 190.07 minus 121. Divide that by 4, and you work that out. And so it's a fraction 190.07 minus 121. And there were 4 of them same, so you only want 1. So it becomes, and it's a 1 decimal place, I'm gonna give them the 2 decimal places again. All right. So it's 17.27 centimeters squared. That is it. 17.27 centimeters squared. All right. That is that. Next question. Number 7. Number 7 says, the table below shows the number of bananas to the nearest ton produced annually on a farm over a period of 6 years. It's a statistics question. All right, so these are the years, and these are the tonnage of banana produced. It says, on graph paper provided on page 21, draw a bar chart to represent the data given in the table above, using 1 centimeter for 1 year on the x-axis and 1 centimeter to represent 25 tons on the y-axis. All right, so plotting these points, let's use this as a bar chart we need. All right, so let's use this same graph that I have here. All right, so let's scale this up. All right, so on the x-axis, we're gonna go how much? 1 centimeter to a year. Remember the bar chart, it must be evenly spaced out, right? So what we can do, we can make 1 centimeter. We can make this be for the bar, for the first bar, 2010. Let's put 2010 for this bar. And then this bar would be for 2011. And this bar would be for 2012. And then this bar will be for 2013. This one will be for 2014. And then the last one out here for 2015. The bars must be evenly spaced on the same size. On the y-axis, it is 1 centimeter to 25 tons, right? So this got 2 centimeters to 50. So this will be 50. This will be 100. This will be 150. This will be 200. This will be 250. This will be 300. I don't went higher than that. So I'm going to label up here. And so that is a ton of banana production in tons. So this is production in tons. And this down here is time in years. Of the year. All right. So the first bar goes up to 150. Let's draw it in blue. Let's draw it in blue. First bar goes up to 150, which is up to here, so to 150. That's the first bar. Can I shade it as well? Second bar goes up to 275. 275 is all the way up to here. This is 275. We're coming up here for 275. So the second bar goes all the way up to there. You can just cross hatch it like that again. The third bar drops down to 100. So 100 is right here on the third bar. The next bar drops down to 40. All right, so we get this 40 good. So since there are 10 lines between 0 and 50, means that every other line is 10. So this is 10, 20, 30, 40 is right here. That's 40. So we're talking about this line right here is 40. The next one is 125. 125. So 125 is this line. This line is 125. So next bar going up to that, 125. The next one goes up to 210. So 200 here. Remember, every line is 10. Every other line is 10. So 210 will be this line. 210 will be that line. So this going up to that line there. And make sure you draw it with the ruler now. Don't draw it friendly like me. That's a bar chart. Nice and easy. All right. Then we have some questions now. I'm going to copy this over just now. First question says, determine the range of the number of banana produced between 2010 to 2015. So the lowest value to the highest value is the range. So it's 270 tons, 275, sorry, minus 40, which is 235 tons is the range. Range of the production, 235. During which year was the greatest production of banana? This year, 2011. Highest production, 2011. Easy. 2011. All right, corresponding to the tallest bar. Question says, how is this shown on the bar chart? Tallest bar. Tallest bar corresponds to the year when you had the highest production. Tallest bar. All right, next bar says, between which two consecutive years was there the greatest change? Well, change can be increase or decrease in the production of banana. So look at the bar chart now. Between which two consecutive years was the greatest change? This looks like the greatest change to me. This right here. But look at the bar chart. This looks like the greatest change. This one from year to year. So that looks like the greatest change. And it's a two consecutive years, side by side years. There's a big drop from 270 down to 100. This drop right here, so by 175 or 175 drop. That's the biggest difference. Even if you look at the numbers, that's going to be the biggest difference. Look at the numbers. This difference inside here says 175. Here, so there's a drop of 175. Right? This one is an increase of 125. This one is a drop of 60. This one is an increase of 85. And this one is an increase of about 100 and something. The biggest change is when it dropped from this to this. So between 2011 and 2012. So between which two consecutive years? 2011 to 2012. 2011 and 2012 are the 2 years. That's the biggest change. It's a change. Never say increase or decrease. It's a change. I make sure they put the word change in bold letters. Then it says, how is this information shown on the bar chart? What would I say? How is this information shown on the bar chart? So the greatest difference in the height of in the height of two consecutive bars, something like that. Right? The greatest difference in the height of two consecutive bars represents this information. All right, but can I agree with that? Online is still there. Online students are still there.
Yes, sir.
Yes, sir.
All right. All right, so that's what we have to say. All right. Yeah, so we say it's the greatest difference in the height of two consecutive bars. All right. Greatest All right. Greatest difference in the height of two consecutive bars. It's those two that will mark. So I'll maybe even leave this on my diagram now so you can see. All right. Greatest difference. I leave this on my thing so you can see what I'm talking about. And let's put it as a measure. So maybe just like this and show it as a measure. Difference, right? All right, difference. So examiner system actually did use my graph. Greatest difference. All right, I can write greatest difference on it. All right, so I'm gonna copy this and put over here on this diagram. Bear with me to get on the same document. All right, that's it. All right, next question. It says, give one reason why the bar chart is unsuitable for predicting the number of bananas produced in 2016. Why is it unsuitable? What would be more suitable? All right, good. So the line graph don't necessarily show upward and downward trend like that. That's why the line graph will be more suitable. Right? So I would say that as well. Line graph is more suitable because it would show upward and downward trend. Bar chart does not show that. Right? All right, so I would say something like line graph is more suitable. The bar graph does not show upward and downward trends as clearly as a line graph. That's the reason. Because the line graph shows upward and downward trends more clearly. It's better to use a line graph to predict what's going to happen next. And what you do, you normally use the average rate of change. And a line graph that can be done simply by joining the starting point and the ending point and extending that for one more period. All right, that's it. That finishes that question. Number 8, pattern question. So makeup time question. It says a sequence of figures is made up of squares of unit side. The first 3 figures in the sequence are shown below. And the first thing one wants us to draw the fourth one. So to draw the fourth one, you realize we just need to add on a square on each side of this thing, right? One up here, so 1 over here, so 1 over here, so and 1 down here. And we'd have our fourth figure. So let's just copy on this one and do the business. So that will be my figure 4. That's it. Nice and easy, figure 4. All right. Next part now says, determine the pattern of numbers in each row of the table below. Each row relates to one of the figure in the sequence. Some rows have not been included. All right. Some rows have not been included. All right. So I like to, as I said, fill out that formula row first. All right. And I see that, for example, these going up by 4. Because they're going up by 4, I know that 4n is a part of the formula. But the first figure only has 1. 4 times 1 is 4, and it's subtract 3 to get the first one. So I have to subtract 3. That becomes a formula. I can test it here. For example, 4 times 2 is 8. 8 minus 3 is 5. So I know the formula is good. All right. Over here, these going up by what? 8. So because they're going up by 8, and we're at 8n is a part of the formula. First figure only has 4. So I need to subtract 4 because 8 1 is 8. 8 minus 4 give me 4. So I need to subtract 4. Then I can test it. Drop, for example, 2 on this. 8 2 is 16. 16 minus 4 is 12. So I know how the formula works. All right. And I can use the formula to fill out the rest of it. So for this one, it's just the one that follows that. I can add a 4 to this. Or I can drop the 4 on this and get 4 4 is 16. 16 minus 3 is 13. So I can put 13 here. Which I almost have to remember this. Go outside, go outside. Then I can drop the 4 on this one, or I can just add 8 to this to get the next one. Like if I drop the 4 on this, I get 32. 32 minus 4 is 28. And we want to look at it, this is 28. Then for this one now, I need to just put this formula equals that to know what the n value is. That's all I need to do. So for this, I'm going to put an arrow. I'm going to put the formula equals 45 to see what the n is. So 4n minus 3 equals 45. Transpose this, I get 48. And so the n equals 12. 12. Now the n is 12. I'm going to drop the n on 12 on this. I get 8 times 12. So right here becomes 8 times 12 minus 4. What that work out to? 8 times 12 is how much? What is work out to? 92? 92? 92. And when this is 30, I just drop the 30 on this. I get 4 times 30 is 120. 120 minus 3 is what? 117. And then I just drop the 30 on this now. I get 240. 240 minus 4 is what? 236. The boy said, I get these figures, just drop them on the formula. That's the beauty about doing it this way. You don't have to do figuring out stuff. Let's use the formula to help us, right? A lot of people use the method where they try to figure out stuff. You don't have to figure out anything where we have the formula. Use the formula. Nice and easy. Put it right here is 8 times 30 minus 4. And for this one, it is 4 times 30 minus 3 using the formula. All right, that is that. That completes that table. Let's move on now to number 9. 9, 10, 11. 3 questions to go. This question said the table below shows pairs of values of x and y where y varies or is inversely proportional to x. Inversely proportional means k over. It says express y in terms of x and a constant. Either y equals k over x. That's it. Inverse proportional. I multiply the x up here, so this also means that xy is always equal to a constant. If I multiply the x up here, this can be very useful. The product of x and y is a constant value. All right? Question says, calculate the value of k. Can use this. K is the product of any x and y value like that, for example. So we can write that the k, for example, is 3 times 2, which is 6, using the first pair. We'll use this one if you want. 4 times 1.5, still gonna get 6. So k is 6. The constant is always 6. Now, down here now, I must find the value of a and b. So from this one, you see that the product of these two also equals 6, don't it? Product is always equal to 6. So a times 1.2 is equal to 6. A times 1.2 is still equal to 6. We're using the fact that xy is always equal to a constant 6. Because the constant is 6 right here, so xy is always equal to 6. This is what we're using. Product is equal to 6. So divide by the 1.2, we get a equals 6 over 1.2. A equals what? A equals 5, right? 5 that? Same as 60 over 12. 5. On the other side, we're going to use this product now. X times y still equals 6. So it's 20b equals 6. So 20 times b, that product is also equal to 6, not 2. 20. 20. So get the b divided by the 20. So the b equals 6 over 20, which is 3 over 10, which is 0.3. Done. All right, that is that. Next question. It says, the diagram below is a graph of this function, quadratic function. Beautiful. They give me the graph. I can get everything I want from the graph, but they give me the graph. Between x value of 0 and 6. Let's see what I want. It says use a graph to solve this equation. Remember, this equation gives you the roots. When you solve a quadratic equation, it leads to the roots. Where are the roots? The roots are these 2 points where the graph intersects the x-axis. Those are the roots. Where the graph intersects the x-axis are the roots. So it's x equals 2, x equals 4. These 2 points are the roots. These are called the roots. When you solve the equation, you get the roots. Keep it simple. All right, next one. Right on the corners of the minimum point. This is the minimum point right here. Let's put on the graph. This point is the minimum point right here. This is a different color for that one. This point is your minimum point. What are the coordinates? 3 is the x value, -1. This is -1. -1 is the y value. So it's 3, -1. Remember, this is the xt and this is the yt. No. So this is like xt and yt, just the same. We're connecting everything. This is actually xt, yt. The x value and the y value are turning point. That's xt and yt. So xt is 3, yt is -1. That's a turning point. So that's the point, 3, -1. Let's write it here. So it is xt, yt, turning point, minimum turning point. It is 3, -1. All right. Next part says we have to basically write it in this form. I have the information, I don't have to work it out. Because this form is similar to a into x minus xt squared plus yt. We may already work out xt is 3 and yt is -1. I can see that on the graph. So I don't have to actually do this process. I don't have to work it out. I have the values because I have the graph. And the A is what? The A is 1. The coefficient of x squared is 1. So we can write that as well. The A is equal to 1. So it means then, if I write this in this format, then it means that x squared minus 6x plus 8 can be written as A, which is 1, into x minus xt is 3. Don't forget the square, and the plus yt, not yt. Plus yt is negative 1, minus 1. That's the answer right here. This is the answer. I don't have to calculate nothing, as I have everything on the graph. I don't have to calculate xt, I don't have to calculate the yt, because xt and yt are the coordinates at the minimum point. You have to remember this. All right? T means turning point. Done. Next one says, on the graph, draw on the graph the line g of x equals x minus 2. You have to be careful. This line is going to cross the y-axis at negative 2. It's going to have a gradient of 1. And number in front of x squared is 1. All right? So let's go. That line is drawn in purple. It's going to pass through minus 2 right here. Cross y-axis at minus 2. Then it has a gradient of 1. So it means that rise over run is going to be equal to 1. 1 is the same as, for example, 2 over 2. They can rise 2, run 2. So rise 2 units, run 2 units. So to get other points, you can rise 2 units. So this is negative 2, you know. Remember, this is negative 2. Right here is negative 2. So if you rise 2 units, it's going to come up to 0. You run 2 units, you're coming over to this point. This point. So that's a point on the line that we want. Rise 2 units again to here. When you run 2 more units, you're going to come over to 4. Run 2 units, you're coming over to 4. So that's another point on the line that you want. Then rise 2 units again. If you rise 2 more units, you're coming up to 4. And you run 2 units. If you run 2 more units, you're coming over to 6. Here, that's another point on the line. So you see, the line that you want passes through those dots. That's a quick way to do it using a point and a gradient. All right, so I'm going to take these out, take out these rides, the rise and run. All right, can really go in. So a straight line through those points will give me what I want. So I'm going through here. Straight line. This is the g of x line right here. I have to draw it with the ruler, guys. This is g of x equals x minus 2. I'm sure they're going to ask us something about these 2 points. So I'm going to mark in red. This point here where they intersect and this point here where they intersect. Those 2 points. Yes, I must ask us something about those 2 points. Those 2 points are where the 2 graphs, 2 equations equal. Right? This first one, x is equal to 2. The second one, x is equal to 4. You can see it. X is equal, no, not 4, 5. Right here, x is equal to 5. You see, they ask you down here. It says, on the same axis, draw the graph, which is done. This was done on the graph. This was done on the graph. And then down here now, it says, hence solve this equation. Now, this equation is where the curve equals, this is the line. Meaning where they intersect. But that's an equation in x. So the answer we want are the x values where they intersect. So it's at x equals 2 and x equals 5. Where they intersect. No, not 5, just 4. 2 and 4. It's 5? Oh, 5. My mistake. X equals 2 and x equals 5. That's where they intersect on the graph. That's what that equation referring to. Points where they intersect, they're given the x values. But the equation that they're solving is an equation in x alone. So it would give you the x values where they intersect. You can see that on the graph. curve and the line intersect at those 2 points, and those are the two x values, 2 and 5. All right, let's continue. That finishes that question. These are the answers. 1, 5. All right, let's go to number 10. Number 10 says the diagram below not drawn to scale shows a circle center O. The vertices H, J, K, and L of a quadrilateral lie on the circumference of a circle. PKM is a tangent. All right? Tangent to a circle at A, the measure of angle HJL is 20 degrees right here, which you can see. And JKL is 50 degrees over here. You can see that as well. All right? Now, this is a diameter now, guys, because it passes through the center. Look again. That's a sector triangle. It's an isosceles because that's a radius and that's a radius. So you can see that. This also is an isosceles triangle. But that's a radius and that's a radius. Those are just some features that you can see right out the back. That's a cyclic quadrilateral, as you can see. The opposite angles are supplementary. That's a tangent and a radius. So this angle is 90 degrees. So means the radius are 40. And this is the angle between the tangent and the chord right here. Tangent and chord. So the chord subtends the same 40 degrees at the circumference up here. So since this angle is 40, this angle up here is also 40. There are some features I'm seeing off the back. But let's answer the question. A lot of things we can see. But let's just answer the questions. Question says, calculate given reasons for each step in your answer the measure of angle HKL. Which angle is that? HKL. HKL. That's this angle down here, so. All right, so we're trying to find that angle. Let's look at it. Trying to find this angle. So we can say, okay, what is subtending that angle? It is this chord that is subtending that angle. What else is the chord doing? It is also subtending an angle up here of 20 degrees in the same segment. So these two angles equal. Angle of the same segment are equal. So this angle is 20 degrees like that one over there. Because both of them subtended by this chord. Angles in the same segment subtended by the same chord are equal. So this angle here is 20 degrees right here. 20 degrees. Let's write it. That angle that I want is 20 degrees. Angles in the same segment subtended by the same chord are equal. So this angle equals 20 degrees. Reason, angles in the same segment are equal. Angles in the same segment are equal. All right, next question. Angle JOK. Angle JOK. That's this one right here. That angle is one of the angles in this isosceles triangle. I will know that this angle here is 50 degrees. So this angle is also 50 degrees. Because it's an isosceles triangle. Right? So those two angles equal. Total angle in isosceles triangle is 180. So this triangle right here is 80. 180 minus the 100. Right? So when I say that that's an isosceles triangle, let's put on the diagram. This angle is 50. Let's put it on there. So this angle right here is 50 degrees. And since these two are up to 100, then this one must be 80. That's what we're going to use. Total angle in the isosceles triangle is 180 degrees. So that angle becomes 180 minus 2 times 50. So this angle becomes 180 degrees minus 2 times 50 degrees. That's why it becomes 80 degrees. That's the reason. Total angle in the isosceles triangle is 180 degrees. Total angle in the isosceles triangle is 180 degrees. That's the reason. Total angle in the isosceles triangle is 180 degrees. That's why we have 2 times 50 right here. All right. Next angle I want is angle JHK. Let's look at which one that is. Angle JHK. So JHK, this one up here. This one. That angle is going to be 40, you know. 2 ways I can know it is 40. One, because this triangle is a right angle triangle. This triangle here. Because this angle is 90 across here. So how many is 90? Because it's subtended by this diameter. So that angle is 90, then them 2 here must add up to 90 as well. So that's why that one is 40. Another reason why it is 40, a reason why I could say it is 40, because this angle that we want up here is subtended by this chord. That chord is subtending 80 degrees at the center. Angular center is twice angular circumference. So the same chord must subtend 40 degrees at the circumference up here. So we could use that. Angular center is twice angular circumference. So the one at the circumference is 40. But understand that?
Yes, sir.
All right, let's do it. So we're going to put that as half of the 80. Let's use that one, angular center. So down here, this angle is going to be half of the 80 degrees at the center, which makes it 40 degrees. The reason is that angle at center is twice angle at circumference. Angle at center is twice angle at circumference. Anything else? Nope. So don't even ask any question about the tangent. So you go, you have to just answer the ask. All right. But good so far? All right, next question. Bearings. Light bearings question. I basically ask the same thing all the time. Just have to practice them. All right? Question says, a ship travels from Akron, A, travels from here, A, on a bearing of 0-30 degrees to B. So it means that from A to B, the bearing is 0-30 degrees. I'm going to put on the diagram right now. Let's put on the diagram right away. No hesitation. So this is my north line. I'm going to extend it up on my diagram like that in the exam room, just the same. And the angle that they told me about now is this one. 0-30 degrees is a clockwise angle from A to B. From the north line, right? Going from A to B. So this is 0-30 degrees. Right here, it's 30 degrees. I'm just going to leave out the 0. 0-30 degrees. That angle is 30 degrees. What is the distance? 90 kilometers. So this distance is 90 kilometers. Put it down there. 90 kilometers is that length, that distance. All right. It says, and then it travels to Compton, which is, read carefully now, 310 kilometers due east of Akron. So from Akron to C to Compton is east. So it means that this bearing is 90 degrees. The bearing of east is 90 degrees. So this is an east-west line. All right, careful now. And I said the distance is 310. So it means that this distance across here is 310. 310 kilometers. Now watch this now. If this angle is 30 and the wall of this is 90, then the angle inside the triangle right here, so it's 60 degrees. I'm putting it in there now. But that's a north-south line and that's an east-west line. The angle between north-south, east-west is 90 degrees. That's what we have. So we're good to go. We can use cosine rule to find this side over here now. Cosine rule. All right? What does that say? That's it. It said to indicate on the diagram the bearing of 0, 30 degrees. That's right here. Maybe I need to put the 0 on it. And the distance of 90 and 310. Let me go back and put the 0 on this thing. Follow instructions. So let me put the 0 there. Since someone show it, let's put the 0 on it. Everything important. So I'm not taking any chances. I want to put it as 0, 30 degrees. 0, 30 degrees. Right there. That angle. 0, 30 degrees. All right. Next part now says calculate the nearest kilometer, the distance from B to C. That's this distance. Cosine rule we have to use because we have two sides and angle between. Cosine rule. Tell the examiner cosine rule, using the cosine rule. Like big people now, can just write BC equals the square root and fill out under the square root sign. This side squared plus this side squared. 90 squared plus 310 squared minus a piece. 2 times the 90 times the 310 times the cosine of the angle between them, which is the 60 degrees right here. 60 degrees. Come on, we're using this enough times now. Right? You have to practice doing it. Don't get a lot of space to work with. See, a small amount of space you get to work with. You don't have time to writing 5 lines unnecessarily. I put this in the calculator and get the distance BC in kilometers. Let's get a calculator and see what it is. What you get? 276. All right. And set to the nearest kilometer, so let's just write it. 276 kilometers. All right. I trust you. So I'm going to put it on the diagram right here as well. This side equals 276 kilometers. Now that I have this pair of angle and side opposite each other, I can use sine rule now to find this angle if I want it and this angle if I want. Those are the only two things in that triangle now that we don't know. Those two angles. But we can use sine rule going forward. Find those angles that we don't know. All right, let's see now. It says calculate the nearest degree angle ABC. So it asks us one of the angles there, ABC. Let's call it alpha and put on the diagram. Angle ABC is this angle up here. Let's call it alpha. So we'll calculate alpha, we'll find it. So we're going to use sine rule. That pair with this pair. Sine rule. Let's work it out on the screen where we are. So we're going to use sine rule for alpha. Put it in red. I can just write it here. Sine rule. Start with what you want. Sine of the alpha over the side opposite the alpha is 310 equals sine of the angle that you know, which is 60 degrees, over the side opposite the 60 degrees is 276. So this is what we have to solve now. We're going to solve for alpha. Let's copy it, cut and paste it down here now. Right here. You can see, guys, I don't give a lot of space to work with. So I keep telling you. That's what we're doing. And we're trying to find alpha. So we're going to do, we're going to multiply by 310 and then take the inverse sign in front of that. So the alpha is going to be sine to the -1 of the 310 times the sine of that 60-degree angle over the 276. That's going to give us our alpha straight out the bat and set to the nearest degree, means that we don't put in a decimal. That's what we're working out. You guys got that as well? One again. How much? Well, you can't put the point because the question says to the nearest degree. You have to follow instructions. It's to the nearest degree. Everything important, you know. The question can't set to the nearest degree and you go put decimal. Follow the instructions. Sine to the -1 of 310 and the sine of 60. Make sure character is in degrees. See there, DEG at the top. Yes, it is in degrees. And you're putting that over 276. That's 76.6 to the nearest degree is 77. All right? 310 times 6 over 276. Yes, 76.6 to the nearest degree is 77 degrees to the nearest degree. So it's 77. So this is what they're looking for, 77. All right, 77 degrees. All right. And then now, what else they want? Determine the bearing of C from B. So remember, you always note the from position. So it's from B to C. So the bearing is done at B. From B to C, the bearing is done at B. Let's put on the diagram. So it's from B to C. So the angle that they really want then is this angle they want right here. This is from position. They want this angle. Let's call it angle theta. Kind of easy to find. Because I know that easy to find. Can do it multiple ways. You can find this angle right here as a first, which is 180 minus this one, because those are co-interior angles. And the total angle around that point is 360. Let's indicate this angle on the diagram. Let's put on the diagram. We can actually do that. We can do the work on the diagram as well. So this angle right here, let's put on in a different color. This angle over this side, which is co-interior with this one. So the two of them add up to 180 degrees. So this angle here is 180 minus 30. Which is 150. So this angle is 150. We just worked out this one is 77. Let's put it on there. This one is 77. So these three angles add up to 360. Total angle around this point is 360. So it means that this angle theta that we want is 360 minus the sum of these two. Let's put it. The angle that we want, theta, becomes 360 minus the 150 and the 77. I'll leave it on the diagram. Sum of those two. All right. So it's 360 minus, and it's on the diagram. I'm leaving it on the diagram. 360 minus 150 and also minus 77. 133. So down here now, we want to set the bearing of it from that. I'm going to say it is theta on my diagram, which is 360 degrees minus the 150 that I have on my diagram and the 77 that I have on my diagram. And it becomes 133 degrees. And that's my answer right there. Already 3 digits. That's my bearing. 133 degrees. Done. But all right? All right, good. I'll come to the next question. This one. It says a matrix T, which is this one, it maps this point onto this point. These are some easy values, you know, but actually let's sketch it out. This point is 2, 3 up here, so 2, 3. P, this is 3. And Q is 2, negative 3. Down here, so. So you can see from this to this is a reflection over the x-axis. I suppose the x-axis reflection matrix is 1, 0, 0, minus 1. More things you know, the better. But let's say I don't know that. You have to work it out. It's always great to know. More you know, the better. Every time. All right? That's an x-axis reflection matrix. So if you were to work it out, because I don't know, what you'd have to do is apply this matrix to this point and put it equal that point. That's how it works, right? So you'd have to say, okay, C0, 0D times this point, which is 2, 3, equals this point, which is 2, negative 3. And you set up the, like you're doing the multiplication. Let's put it in red now. So multiply the rows of the first matrix by the columns of the second matrix. So this 2 right here is a product of this row and this column. All right, so you could set that up. You could say this row times this column equals 2. So you do this row times this column. First element times first element, that is 2C, plus second element times second element, that is 0. That equals 2. So if 2C equals 2, then C equals 1. And this row times this column equals this negative 3. So it will be 0 times 2 and D times 3 equals the negative 3. So the 0 times 2 is 0 plus the D times 3 is 3D, and that all equal negative 3. Now if 3D equals negative 3, then D equals negative 1. But you should have known that already. So the answer is that A equals 1 and D equals negative 1. So C equals 1 and D equals negative 1. Those are the answers. All right, so that becomes the matrix. It says, determine the image of this point under the same transformation. Easy. Minus 1, 5, minus 5, 4, sorry. But you notice that, look at it. The X value stays the same and the Y value change sign. And that's all you have to do, apply the matrix the same way. The X value stays the same and the Y value change sign. That's it. Simple as that. So whatever the matrix does to one point, in terms of how it changes the values, does it to the other point. All other points. You don't have to actually calculate it. So because the 2 stays as 2, the X value stays the same, the Y value change sign, you just do that to this point as well. So the image of this under the same transformation, the X value stays the same, and the Y value changes sign. That's the answer right there. Easy. He said, describe the transformations, a reflection in the x-axis. Because it's the matrix 1, 0, 0, negative 1. That's the x-axis reflection matrix. Some people have to sketch all these points to see it. It's good when you know the matrix. Always easier. A reflection in the x-axis. A reflection in the x-axis. Or I could say the line y equals 0. Remember the x-axis is the line y equals 0? We say the line y equals 0. X-axis is the same as the line y equals 0. X-axis is the line y equals 0. That's it. Next one. Find the matrix which maps Q back to P. To go from Q back to P, you have to go reflect back into the same x-axis. The inverse of a reflection, so you have to use the inverse of T. So the matrix on the map, T back to Q back to T, you have to reflect back in the same x-axis. The inverse of a reflection is the same reflection. The same mirror line that reflects is going to have to reverse the reflection. So that matrix that they want, Q is mapped back to P with T to the minus 1, the inverse of T. Inverse of T. But the inverse of T, because a reflection matrix that is equal to T. The inverse of a reflection is the same reflection, which is the same matrix, 1, 0, 0, minus 1. I'm not going to waste time and work it out. I cannot penalize for advanced knowledge, for knowing that the inverse of a reflection is the same reflection. So I will present it to them like that. Q is mapped onto T using the inverse of T. So the no says the inverse I want. The inverse will reverse the mapping. But if you want to waste time and calculate it, all that's going to happen, you're going to get by the same matrix. Because the inverse of a reflection is the same reflection. The same mirror line that you reflect into, you have to reflect in the same line to reverse that reflection. So the same reflection matrix, if you calculate. The inverse of any reflection matrix is the same matrix you're gonna get. The y-axis reflection, x-axis reflection, y equals x, y equals minus x, all of those mirror lines, reflection matrices, the inverse is gonna give about the same matrix if you calculate it. If you want to go and test it, like calculate out this one, and you're gonna see that you get about the same matrix. All right, but we have to learn to do the mathematics the easy way. That is it. So this is the answer right here. Same matrix. T to the minus 1 and T is the same matrix because they are reflection matrices. The line reflection matrices. All right. This part now says the graph below shows P, Q, and R relative to O. All right. So P, Q, and R relative to an origin O. It says write in this vector form the vector OP. Now P has coordinates 4, -1. Let's write them down. P is a point 4, -1. Q is a point 0, 2. R is a point 3, 7. 3, 7. R is a point 3, 7. So it means that OP will have the same values as the coordinates. So it is equal to 4, -1. Then we want QR. We can look at the diagram and say, go from Q to R. How many units left or right, how many units up or down? Look at it. To go from Q to R, and the diagram is telling me go 3 units to the right to there, and then 1, 2, 3, 4, 5 units up. So I'm telling you that QR is 3, 5 on the diagram, as I have the diagram, so I can count it off. But you can calculate it as well, like this. And so QR is OR minus OQ. O times the last minus O times the first. OR, we said, is this one, 3, 7, minus OQ from this one, 0, 2. 3 minus 0 is 3. 7 minus 2 is 5. So you get the same 3, 5 matrix that I told you up here, that the diagram is showing you. So the diagram and your calculation must be consistent with each other. So you can accept the answer like that, 3, 5. Diagram showing you 3, 5, calculation showing you 3, 5, just the same. All right, that is that. Next part says, what is the magnitude of QR? The magnitude of QR, remember, this is the line we're talking about. And the coordinates on it is 3, 5. You break it down into 2 particular coordinates. That becomes the length, the modulus of the length of that line. Pythagoras theorem says it is the square root of 3 squared plus 5 squared. But using the vector formula for modulus, you're going to get the same thing. All right? And don't go say it's a 3, 4, 5 triangle because the longest side is the hypotenuse, it's not 5. So because the QR is equal to 3, 5, you can use the method where we say the modulus of QR now, and the length of the vector QR, become the square root of this value squared plus that value squared. Because it really comes from Pythagoras' theorem. Don't put 4. This is 9 and 25, don't it? That's square root of 34. Square root of 34 units. That becomes the square root of 34 units. You can leave that as my answer. I have to work it out. But it's not exact. 25 and 9 is 34. Right? This is 25 and this is 9. Third or fourth. I don't have to work it out. You can leave it like that. It's okay to leave it like that. Next part says, on the graph, draw the vector OS 7, 4. So if OS is 7, 4, it means that S is a point 7, 4 with the same values. But it's must draw the vector OS and then show that PQRS is a parallelogram. It's the last question to end the test. Wow. All right. We're done. Let's just finish this. So I'm going to put on the point 7S first, 7, 4 first. Point S on the diagram. 7, 4. Let's put it on the diagram so we can visualize. 7, 4. 7 out here, so 4 up here, so talking about this point. 7, 4 is right here. Right here. That's where S is. And they're talking about this parallelogram now. They're marking out in blue. PQRS. Now, to show that it's a parallelogram, you have to show that the opposite sides are equal vectors. Parallelogram is such that the opposite sides are equal vectors. So let's mark down what we have to show. And we want to use what we have already as well. So we have the vector QR already, right? Here we have QR. So we're going to use that. We don't have to recalculate that one. QR, which is this. So we have to show us that PS over here so is equal to QR. That is PS. And then now we have this PQ. We don't have it, but PQ. Of course, the PQ and SR is the same. This is PQ. This is SR. All right. Let me show what we show. We need to show. To show it's a parallelogram. To show it's a parallelogram, we need to show that the PS can give me a warm time. Finishing up. PS is equal to QR. That's one. And we also have to show that PQ is equal to SR. That's what we have to show that it's a parallel. And the opposite sides are equal vectors. All right, it's going to work them out, show that they are the same, and then we're good. That's it. All right, so I'm leaving this on the exam paper to you know, that telling him that this is what I need to do. All right, so because I already know QR is 3.5, right? QR was 3.5. Just need now to show that PS is also Q5. All right, so let's go blue. So PS is equal to OS minus OP, which is equal to the OS becomes 7.4 minus OP. What was OP again? OP was 4, -1. 4, -1. This works out to be 4 minus 7 minus 4 is 3. 4 minus minus give you a +1. 4 + 1 is 5. And this was PQ. This was already PQ. So I can write this note as, no, not PQ, QR, I mean QR. So I'm going to show this already. Right here, so. So therefore, shown. This part is shown. This is show that part here now. I think I'll have to calculate two of them. PQ and SP. So this is a PQ right here. PQ is OQ out on the last minus out on the first. What was OQ again? OQ was 0.2 on the y-axis. And P is 4, -1. This works out to -4. This becomes a 3. Minus minus is plus. This becomes a 3. Then I need to work out SP now. So SP beside it. SP is OP minus OS. OP is 4 negative 1 minus OS is 7 4 right here. And this works out to be 4, got a mistake, SP, somewhere around. And I get in the same thing. PQ, let's look at PQ. What was P and Q again? Let's make sure. Q was 0, 2, yeah. And P was 4 negative 1. All right. So PQ is OQ. 0 minus 4 negative 4. And it's not working out. SP, PQ and SP. PQ and SP. SP is 4 7. Why not SP more, man? SR, not SP, SR. My mistake. SR we want. SR. SR right here we need to show. SR. SR, not SP. SR. So it's SR we need to be calculating here. So SR. Right. So it's OR minus OS. The OR is what again? The OR was 3 7. 3 7. So the OR is 3 7 minus the OS is 7 4. This works out to be 3 minus 7 is negative 4. And then 7 minus 4 is 3. And so this now can show that this and this equal the same thing. So we have that as well. We have that the PQ equals the SR. And therefore the other part of it is shown. That's it. So we have shown us. I'm telling the examiner that I need to show this. I'm going to show them here and there. So we basically solve the question. I'm telling them I need to show this. I'm writing, need to show. Tell the examiner that I need to show these two things. And I then proceeded to show them. So I need to show this, to show that it's a parallelogram. I need to show these two things. And I've done it for both of them. I show the first one, this one up here. I'm going to show the second one down here. So both of them shown, so I've satisfied that that's a parallelogram. But okay with that? But good? All right, let me hear some grades now. I say it's only 30 you need to get percent on this one. Still have 6 weeks to go. Next week we're moving up to 45. No, next week we're moving up to 40. Right? We have to improve every week. You improve by redoing the questions that you get wrong in particular. So if you do one question 5 times, you do it. Master every question you get wrong. The video is there to help you. Watch about the video, you do the questions as many times as you have to. This is nothing strange. This is what we have learned in class. You just need to practice for it to stick with you and for it to be cemented in your brain. All right? That's all you need to do. So any question that you didn't get right, you go and you redo it. Do it as many times as you have to. Use the video to help. All right? Look back at what we did. Look back at the explanation. Redo it. If you're still having a problem, contact me, let me know. If we can explain it to you a different way. All right? But you shouldn't have a problem. This is not new to you, just that you need practice. There's nothing new to you in these questions, just that you need practice. Nothing difficult in the questions. Online students, you okay?
Yes, sir.
Yes, sir. Yes, sir.
All right.
Yes, sir.
So send me a WhatsApp of how many you got, how much you got as a percentage on this paper. Remember you're marking out a 135. So a 135 marks paper. So check up how many marks you got. Divided by 135, send me the percentage. Let me know how much you got. All right, I'm going to end the session now online for the students in the class. That's all we're going to do now. Tell me how many I got. So you guys online can just send me a message. Let me see how many I got. Cool? All right, let me see what's happening here. All right, guys, I'm going to end it now. Bye, everybody. Bye, Jada. Bye, Shani. Jamil, okay? Nobody answer. Jude. Oh, they're gone already. They're gone already, you know. All the people are gone already. No, Shani is gone. Shani. Shakil.
Yes, sir.
Yes, sir.
Why not tell me how much you got? Send me the WhatsApp how many you got. Everybody. Jonathan. Mr.
Yes,
Steer.
yes, sir.
All right. Send me the WhatsApp how much you got. Everybody. All right. Dijon. Jamil. Levy. Orlando. Ramel. Everybody, send what you got. Who is this? Rush? All right. Bye, everybody. I'm going to end it now. Bye. See you tomorrow. Remember, tomorrow, 11 a.m. again. Going to the other paper tomorrow, 11 a.m. Face-to-face here for the Monday students. You guys here coming online. Bye, everybody.